If you're going through hell, 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 keep going. Fall down 5 times right.
Hi, I'm Pete Zachary. I'm a student of INFA 729 Advanced Web Hacking. This slideshow summarizes Chapter 15 from the Web Application Hacker's Handbook, otherwise known as WAHH, which curiously enough is a sound I make often lately when complaining about my workload. Enough complaining from me. Let's do it. Okay, so let's talk a little bit about error messages. Do we need them? Yes, we do. Is anyone saying we should get rid of them? No, that's not the case. We absolutely need them. They provide information when things don't go as expected. Anyone who has ever programmed knows that they are extremely helpful when troubleshooting, tracing, and debugging applications. So what's the big deal about error messages? Well, sometimes the debugging routines we insert are not removed when the application moves to a production environment. If these code paths are executed, they may provide too much detail and undermine the security of our application. Sometimes they are not our routines per se, but they are the result of unhandled error conditions. The result is the same. Too much information about our application's internals are exposed to a potential attacker. The goal is to return a generic error, perhaps with a code that can provide the developer some insights on what conditions occurred to make the application fail. In this example, a very generic error message is provided. When the session ID was modified, and the application was presented with the situation where either no cart was found for that session ID or the user's permissions were not appropriate to view another user's cart, a generic error message is displayed. All the user knows is the cart is empty. No additional information that can be used to exploit the application has been provided. This is another example of a generic error message. Using burp proxy, the parameters that were submitted to the database were modified. The application returned a generic error message. In an attempt to learn more about an application and understand where it might be vulnerable, attackers probed the application. By supplying bad or unexpected inputs or modifying the state, the attacker attempts to get the application to provide information on the internals. Depending on the error message returned, it may provide insights to help the attacker map the fields of a cookie, identify application components and version numbers, which can then be researched to identify known vulnerabilities. After all, why reinvent the wheel if there's already a known exploit for attacking a particular version of one of the components? Additionally, the error message may contain feedback that allows the attacker to understand the associated data type of a parameter or variable used by the application. Once they know the data type, they can refine the input to reflect borderline conditions or attempt to overflow buffers associated with integer types to create unanticipated error conditions and see what information the application gives up. This slide is an example of the attacker catching a request in burp proxy, modifying the input to probe for an SQL injection vulnerability. In this case, the application returned some information which identified the type of database that was used, as well as the line number and page the error was generated on. I think with further probing, I would find that this application is vulnerable to SQL injection. So what is the attacker's goal? Well, they'd like to know as much as possible. Any insights into the logic used, understanding the code path, and especially the input filtering strategy would be very useful to accomplish their mission, exploiting an application. They are really looking for error messages that provide another potential attack vector. If you can find out the components of my application along with the version numbers, you have something to go on. This is called actionable intelligence. It reflects that you've learned something new that you can research further or directly attack. It's information that allows you to create additional action items. From the developer's perspective, the worst case scenario, other than a full compromise, is if the attacker can create error conditions that generate unhandled stack traces. Stack traces can be considered the holy grail of information disclosure. They can provide considerable information to further an attack in the event unhandled exceptions occur. They might contain the name of the database or database tables, names of variables, names of users or service accounts used by the application to operate or interface with the database. They may also contain procedure names that can be used to identify the application's flow. Okay, now we're going to talk about some tips for probing an application in an attempt to have it generate errors that disclose information to us. Capturing, manipulating, and forwarding requests to the application work well. In some instances, you might be able to do some of this without a proxy, by editing the query strings or parameters in the URL. But there might be a script that scrubs the input before it's forwarded. That's why using a proxy can be much more effective. It allows you to modify the data just before it is forwarded back to the server after any client-side controls have already been enforced. Remember, monitor the responses. Remember, all the valuable data may not necessarily be displayed on the screen. Search responses for keywords. You can automate a lot of this using Burp. Consider using Burp's grep functionality to automate some of this also. Once you're able to generate some errors, search the internet for the error messages. They may be closely related to known vulnerabilities. They may identify third-party application that is integrated into the site. They may even be generated by open source applications that you can access and read through the source code. Always remember to take what's given for free. Many web applications provide user documentation to assist new users. Topics include how to pick usernames and passwords so that new users know that they are compatible with the application. Knowing what character sets are permitted may go a long way towards helping you set up a brute force attack, or just understanding what is not valid so you can create your own error conditions. So remember, during the information gathering stage, you may find all kinds of valuable information that can save you time. Read the facts. Read everything that's made available by the developers. Digest the information they provide to better understand the application's authentication parameters, what's valid and what's not valid. And remember, always monitor the responses. In the example above, the input using Burp proxy was provided to the application that created an error condition. In this case, it was displayed on the screen, but that may not always be the case. This is why it's important to catch the response in a proxy and review them. Perhaps errors are being returned that provide more detail than what is being displayed to the user. Using inference. Many error messages provide insights and allow you to make inferences. For example, in a case where the first thing you need is a valid account name, why not just attempt to create a new account and see what the application returns? Does it tell you that the ID that you wanted is already in use? This is valuable information. We're halfway there. Now we just need the password. Other cases of using inference are when you can search through indices and identify that information exists even though you may not have access to it. For example, you know there exists a confidential report or publication, although you cannot access it due to the access controls that protect it. But the important thing is that you know that indeed it does exist. Response timing is another way to use inference. Suppose you were trying to hijack another user's session. Maybe you first need to know which accounts are associated with active sessions at a particular point in time. You may find that there are timing differences and that active accounts are cached while inactive accounts need to be loaded, requiring potentially another 2 seconds. This is an example of inference like we discussed. Suppose you know a guy, his name is Michael Jones. For some reason, he's being targeted. Say you don't have particularly a piece of email from him, so you try different variations of what you think his user ID might be in Google, and you can see if accounts do indeed exist for a given user ID. Here's another circumstance where we can use inferences. Perhaps I go to a site. Particularly, in this example, let's say it's a pornographic site. I would like to know if my target has registered an ID. So I go to the forgotten password link. If I know his email address, I can query the site to find out if he's ever registered. Perhaps I'm the spouse. I can go to the site and through inference, I can find out if my mate has registered and has an active membership on the site. So how do we prevent applications from exposing important information regarding application internals in information disclosure attacks? The items here listed are provided to developers as some recommendations on how to limit information disclosure through error messages. Number 1 is handle exceptions. Suppress unexpected errors and throw up a generic error page. Write more detailed information into a secured log if you need it, but don't present it to the user. Focus on the sensitive items. Scrub account names, passwords, and credit card numbers from all errors returned to the user. Think hard about when you need to display, or for that matter, when you need to include error information in responses. Truncate or obfuscate the detail. After all, the user is not likely going to need the details anyway. Most of all, do not underestimate the attacker's ability to reverse and circumvent the client-side controls. Make sure you implement them on the server side. This concludes my presentation from Chapter 15 of the Web Application Hacker's Handbook. Wah! I hope you enjoyed it. I'll see you next time.